The objective for this video is to learn how to calculate probabilities associated with a Poisson experiment. A Poisson experiment is a probability experiment that satisfies the following requirements. 1. The random variable x is the number of occurrences of an event over some interval, for example, length, area, volume, or period of time, etc. 2. The occurrences occur randomly. 3. The occurrences are independent of one another. 4. The average number of occurrences over an interval is known. The Greek letter lambda will be used to symbolize the mean number of occurrences over an interval. X represents the number of occurrences over an interval for which a probability will be calculated. The formula for the Poisson distribution involves substituting lambda and x, where x is a counting number. Flaws in coaxial cable can result in degradation of audio signal. Suppose a particular grade of coaxial cable has a random distribution of flaws that occur with an average of 0.067 flaws per foot. What is the probability that a 100-foot section of this grade of cable would have exactly 3 flaws? We must first calculate the mean number of flaws over a 100-foot section. We would do this by multiplying 0.067 flaws per foot by 100 feet to wind up with a mean of 6.7 flaws per 100-foot section. We will substitute the value 6.7 and 3 into the formula for a Poisson distribution. This will result in a probability of 0.0617. What is the probability that a 100-foot section of this grade of cable would have no more than 2 flaws? The probability that there would be no more than 2 flaws is the same as the probability that there would be 0 flaws or 1 flaw or 2 flaws. Since these events are mutually exclusive, this probability would be calculated by summing these individual probabilities. Lambda does not change in this case. We still have a 100-foot section of cable with the same average number of flaws per foot. So we will substitute again into the formula, this time with 0 flaws, 1 flaw, and then 2 flaws. Performing the calculation with the formula, we find a probability of 0.0370. What is the probability that a 100-foot section of this grade of cable would have at least 3 flaws? Again, lambda will not change in this case. And what we must realize is that the probability that there would be at least 3 flaws is the complement to the probability that there would be no more than 2 flaws, which we calculated a moment ago. So the probability that there would be at least 3 flaws would be equal to 1 minus the probability that there would be no more than 2 flaws. Performing this calculation, we find a probability of 0.9630. In this video, we learned how to calculate probabilities associated with a Poisson experiment.